Hello everyone, welcome to today's PACE webinar on using bill of materials cost forecasting to drive profitability. It's my great pleasure to have Michael Ray as our presenter today. He's Managing Director and co-founder of PlaidCloud. He has 20 years of experience in financial analytics, integrating operational research into sustainable business processes. He's a subject matter expert in cost analytics, intercompany invoicing, and profitability and cost management. Throughout his career, he's consistently been a strong advocate for open source technologies. He's earned his BS and MBA from Carnegie Mellon University. For those of you that aren't familiar with PACE, we're the Profitability Analytics Center of Excellence. We're a group of volunteer professionals dedicated to helping organizations make better, more informed decisions through the use of data analytics. If you'd like to become a member, it's free. You'll get access to other webinars, podcasts, articles, ebooks, interest groups, and much, much more. Go to our website, profitability-analytics.org, and sign up. We have a little bit of housekeeping here first. If you'd like to receive a certificate of attendance for today, please be sure to use your actual first and last name when you sign in. If you need to edit the name on the screen, click Participants, which is located at the bottom of your screen, and then hover over your name on the list. Click the three dots, and there's an option there to rename. Please note you must attend at least 50 minutes of this presentation and answer at least 3 of the polling questions to receive a certificate. I will note this session is being recorded, so please keep your camera off and your microphones on mute until the Q&A session. Mike will be taking questions throughout his presentation, so feel free to enter them in the chat feature as we go along. Having said that, over to you, Mike.
All right, great, thank you. So thank you for the introduction, Rafe, and so looking forward to getting started and discussing the power of granular precision and using bill of material forecasting to drive profitability. Over the course of the next hour, we'll we've really covered the introduction, but we'll go through the objectives, some definitions, challenges, a solution and benefits, and a brief case study and some additional considerations. And then at the end, we'll have time for questions. However, like Rafe said, if anybody has questions along the way, please ask them. I'm happy to take any questions. And I'll start out during the definitions, kind of laying out what we call a BOM and what a bill of material actually is and what it means in the context of what we're doing here. But if any of that requires some elaboration, if I miss something, by all means, hit me up. All right. So moving on. So objectives. Number 1 is to demonstrate how to streamline the bill of materials cost forecasting process by applying up-to-date data integration and analytics tools like PlaidCloud. There are other tools as well. However, as you'll see during the later discussion, a lot of what happens when companies attempt to forecast costs at the BOM level, it's done in a way that's typically not very effective or efficient, reverting to like kind of lowest common denominator Excel type approaches, because what we're going to discuss ought to be done in a lot of manufacturing businesses is really not handled by the ERP system or planning and consolidation systems. We'll also discuss at least 3 cost drivers like raw material, currency fluctuations, tariffs, engineering changes, and how they impact profitability. And then we'll identify a couple of emerging technologies that potentially can enhance profit optimization and accuracy. And then we'll gain insights from bill of materials cost forecasting a case study of ours with one of our clients, and also then show how advanced forecasting methods can enable a company to increase profit, and really primarily by reducing costs, but then also potentially strategically helping a company to use the BOM information to maybe guide what products they should be in. And there's impacts beyond just cost that actually impact the revenue side of the P&L as well. So moving on, what I wanted to do here was start with what is a BOM. And so a BOM is a bill of material. and it's a comprehensive roll-up of all of the components and sub-assemblies that make a final assembly. That's the typical BOM. There are other cases where it's a little bit more semantically different, like in a process industry, like what is a BOM if you're making cold rolled steel. It's a different sort of thing, but it's still ultimately typically components and typically sub-assemblies that are rolling up to make a final assembly. Think of like a computer. It's all the different components, hard drives and screens and keyboards that make up a computer, and all of that rolls up. And for our conversation today, there are at least 3 or 4 different types of bill of materials. The engineering BOM, which has all the engineering information associated with it and parts all the way down the hierarchy. Planning BOM, also like the MRP BOM, which is what you would see in SAP or Oracle or an MRP system. And then the purchasing BOM, which some companies have such a thing as a version of a bill of material inside of their planning system. Others don't, and then that reverts to being sort of a hodgepodge of Excel and offline systems sometimes if there's nothing else there. So a closer look at what's in a bill of material. So a bill of material is a roll-up of components. As you see here, the little green dots would represent components here, rolling up to a sub-assemblies that then roll up to a final assembly. And that information includes the part numbers of each sub-assembly and also the quantity of a given sub-assembly or component in a higher level assembly, as well as the cost. And so what you see here is an example of something where we have costs multiplied by quantity to get an extended cost and a total quantity calculation. And that's in essence, that's the primary things that are included in the bill of material. There are other information that's also important. I'll talk later more about BOM routings. And so a given material that rolls up into a higher level material in a bill of materials needs to know where it comes from. And so that can mean either if something is all in-house manufactured, or if a sub-assembly is purchased from the outside or from a different entity within a corporation. That information also resides on the BOM, kind of where a part is coming from, where it's going to, what it is, and what parts it rolls up to are all relevant pieces of a bill of material. Beyond that, the manufacturing BOM typically has a buildup of the different types of costs that make up a bill of material. And those can be, standard costs, manufacturing variances, labor costs, labor variances, and sometimes MRP systems will attempt to layer in like burden rates and overheads. They're typically, our experience, when we get in talk about how those like an ERP system allocates those types of costs, is typically not done with a lot of precision, which is one of the main reasons to have maybe a better costing system for this types of analysis than just to rely on the MRP system. And also, I started to touch on it, but there's master data associated with the bill of materials, including who supplies it, who manufactures it, what's the supplier's part number if you need to tie back to your supplier, and then that can even go down multiple levels down. One of the examples that we're going to look at in the case study here today actually discusses what we call an own design manufacturer that has a number of different suppliers that roll up to that manufacturer. Think of like the electronics. Think about your phone, your Apple or Samsung phone in your pocket. Apple's not manufacturing that thing from the ground up. They're buying very high level, things that are already built, and they're slapping them together and putting them in a box. And so there's can be a 8-10 tier supply chain beneath there that is the BOM that they're actually managing. So, and I mentioned earlier different types of BOMs and where they reside within a company. So a bill of material, typically the first bill of material in a company is going to be the engineering BOM as a product is designed typically, and that exists in an engineering system. And that bill of material will look a lot like the manufacturing BOM, but it'll have different attributes in it, oftentimes like revision levels, and it won't have things like supplier and some of the other master data that comes along for the ride in a manufacturing BOM. But generally overlap, but they're different things. And then oftentimes, I mentioned there's a purchasing BOM, but oftentimes that exists kind of as like borrowed from the manufacturing BOM, and it doesn't necessarily always exist in a system. And so oftentimes, especially in the own design manufacturer, contract manufacturer circumstance type of business, we see like the purchasing and procurement organization is managing their view of a bill of material in Excel. And that has its limitations. It's obviously super flexible. It has its limitations though in data size, scalability, consistency, accuracy. And then cost modeling, forecasting BOM typically doesn't exist anywhere in a company. Oftentimes, a lot of companies are not really driving their sales forecast all the way down through the bill of materials to know what the total consumption is of everything across the whole company. And I'd say a lot of companies do that. That's what an MRP is for, but a lot of companies don't. And the reason is that they don't own everything down all the way through down the supply chain that's reflected in the multiple levels of the BOM. And so there's really not a place in the MRP system for that data to exist sometimes. So actually, before I jump into this, there was one thing I wanted to jump into a dashboard for just for a minute, because so PACE as an organization is focused on helping companies manage profitability, hopefully gain profitability, and oftentimes we think about like by understanding what profitability is, what makes up profitability, and what the types of costs are that subtract from gross sales to get to that enterprise profit level. And thus, frankly, like a big part of our business is allocating indirect costs, overheads, freight, sales, marketing, R&D, anything that's in OpEx down to a sales transaction level, so that we can build a segmented P&L that allows a company to see a P&L by product or product family, customer, channel, that sort of thing. And all that level of detail, and which can then be analyzed and broken out in all sorts of detail. However, all of these things that I talked about, we assign costs using, like, say, driver-based methodologies for, that get you from gross profit to enterprise profit. Those are the little bars in this chart. The BOM is the COGS, and it's typically a bigger portion of the overall cost structure of a company than all of the OpEx related costs and freight and distribution costs. Not always that way, but very commonly, this is a big thing to understand. And sometimes a company doesn't know truly what's in their COGS as well as they think they do. It's the MRP system has standard-based COGS, some attempts at standard actual variances. But when it comes to rolling things up especially in a distributed supply chain or supply web, the COGS numbers that they have are often not really as accurate as one would wish they would be. Let's pop back to the presentation here. Full screen. Okay, so what is BOM forecasting? Now that we've discussed what a bill of material is, let's talk about what it means to do bill of material forecasting. And so what that effectively is it's taking the entire bill of material, including all of the quantity of each of the sub-assemblies all the way down the tree, and then multiplying all of that by the sales volume of each finished good. So if this is part number FRBMC3, so it has a sales forecast, out, say, a number of months, say 12 or 18 months, and we want to then basically do the math. BOM forecasting is doing the math of crossing that sales forecast with all of the details inside of that bill of material. So again, imagine if we're producing computers all the way down to like the little screws that hold the bottom of your laptop onto your laptop. There's 4 of those in a computer, and then that rolls up, or in one part of the computer, there's 6 in another part of the computer, there's 20 in another part of the computer, and you end up with 28 set screws in this particular model of computer. And then you have that model of computer times its sales forecast. However, that same screw can exist in 500 different models. And so if you wanted to know what's the total consumed of that screw by the parent company, there's a bit of math to do. And that's not something that is easy to just dump out of any other system, including your MRP system in your company. It's something that you have to actually go after if you want to know what that answer is the data is there to figure it out, but most companies aren't really figuring out as well as they could, and they're basically using some sort of high-level estimate in a spreadsheet to try to guesstimate what those numbers are when they look at consumption of low-level components inside of a high-level assembly, especially if they're not manufacturing that entire thing in-house. If they're buying use a car analogy, a radiator from a supplier, they don't necessarily keep track of how many screws and bolts are in that radiator, and have a way to roll that up and guide it against their sales forecast. So why is the math that I just showed here, why is it worth doing? You're going to create a lot of data by multiplying all of the individual BOM quantities times all the way up the tree, and then multiplying that by your sales forecast. You're going to create a volume of data that has value in the company, and this is why we're here. This is why it's worth considering having a system that can do this sort of math reliably. One is cost outlooking. So it's to assess the potential value of future changes to the bill of material, typically engineering changes. But there could also be other types of changes. So what that would mean is, if say there's a group of final assemblies that uses a certain hard drive, and you can change that to a different hard drive and save 10 cents. You want to cross that with all of the computers that use said hard drive. Some of them use 2, some of them might use 3, to get all those volumes right, and then multiply that by the sales volume, the forecasted sales volume that say comes from commercial in an organization, to determine what the total spend on hard drives will be for a company. And then multiply that by, say, add to that other hard drives that are coming from the same manufacturer, and you can use this sort of information to then look at, say, hard drives or screws, it doesn't matter, but to look at the sum product of that data and actually know how much you're going to spend over the course of a year, 2 years, 3 years, which is also useful for supplier management negotiation. I should back on the costing side, I should mention. So if a cost can be reduced by, say, engineering a cheaper hard drive that does the same thing, that math allows you to see what the benefit of that, what the financial impact is of that change. And then beyond that, knowing the total volume consumed of a screw or hard drive or anything else allows you to then figure out which suppliers to use if you want to make a change, and also gives a company greater leverage in a negotiation conversation, because they actually have on paper information that they know to be as correct as possible, indicating indicating how much total they expect to spend. And I do see here, there's a question popped in the chat a moment ago. So the MRP is doing the math most of the time. So it isn't always doing the math, and it's typically not doing the math on it should do basically the total consumption math correctly. It's typically not doing any forecasting of what cost takeouts will be in the future. It's more like a what if scenario type of thing that's happening that hasn't made it into the MRP yet. So to answer Sabe's question, one of the values here is around actually being able to determine what if scenarios to allow yourself to play out if we have potential engineering changes, but they're going to each have their own investment and then a payoff over, say, 2 years where a re-engineered product would be in production. The upfront analysis, the cost benefit analysis, do I spend $1 million on a new piece of equipment that makes a cheaper subassembly, or do I not? I want to know what the potential impact is. If that saves me $1 per thing that I sell, and that I'm going to sell 2 million of those things in the future, I want to have a reliable way to get that consumption estimate out. And MRPs don't typically have that type of information that far out, especially for like the what if scenario where you can forecast, a potential BOM, like a proposed BOM, as opposed to an actual in production bill of materials. Um, Another thing here is strategic planning. I mentioned the value of doing what if analyses with a BOM forecasting tool. We've seen the implementations we've done be useful for analyzing onshoring versus offshoring. Also ties that back directly into disaster preparedness, which I'll get to in a minute. But impacts of different types of costs, supply costs due to potential tariffs. There's something that is kind of timely right now, that it would be nice to be able to make an adjustment, to pull a slider and increase the certain cost because product is coming from a certain country, and be able to see what that's going to do overall to the whole business quickly, and not have it be like a really high level, kind of thumb in the air estimate. And then lastly, to model, I should have mentioned in here also for material costs themselves. A lot of products are indexed over time, that they're going to go up or down, a degree based on, what's going to happen with the price of copper, what's going to happen with the price of steel or some resin. And with a BOM forecasting model, certain components can be tied to certain materials, and there's like a coefficient where those can be dialed up or down based on what you think is going to happen, and to play out a few scenarios that way as well. And lastly, disaster preparedness. So this is something that actually helped us get traction in the marketplace with some of what we do, and for existing implementations, kind of enabled our tool to help a client solve problems they didn't have initially. Not a good thing, but hey, there's natural disasters happen, Texas ice storm, COVID, other types of things happen where COVID basically caused the U.S. to want to, there were times where there was concerns about getting products out of China, and if a lot of your supply chain is chunks of it are critical, are coming from China, if ports close, what's going to happen? And given the possibility of a shortage of some components, this is an important thing to try to answer. Which products can we build, and which products should we build if we are supply constrained? We don't want to build 90% of a computer times a million. We want to build 500,000 computers if we're supply constrained, but we want to build 100% of the computers so we can actually ship it. And thinking back to like not our client, but I think a lot of folks on the call might remember, during COVID there was a chip shortage, and so automotive was really hard hit. Other industries that use chips were hit as well. Ford was actually shipping trucks to dealer lots because they had a truck that was 90% done, didn't have the computer chip and the computer all in the truck, but they wanted to keep things running, so they kept on making product that was not sellable, and so then pushing it all the way even out to the dealer lots. And answering those types of problems are something that you get out of BOM forecasting analysis, implementing the supply constraints. All right. So challenges in bill of material cost forecasting, how to model engineering requirements and cost reduction initiatives. So I have a comment here that most MRPs attempt to do this. They do to a degree. And MRP does can do a lot of things. If you had one MRP system, you also wouldn't necessarily, you wouldn't need a reporting layer on top. You wouldn't even need a planning and consolidation system. But these other systems across the top for BI have value for doing what if type analyses that you typically just don't see in clients that run big ERPs like SAP, for instance. How to manage properly model impact of cost drivers. I already touched on this, but commodity prices, shortages, yes, ERPs do that, and tariffs. But the what if aspect of a dedicated forecasting model is likely going to oftentimes outrun the capabilities of what you can do in an ERP. All right. So challenges in bill of material forecasting. So the purpose of oops, there we go. Mouse is moving on me. So the purpose of a bill of material cost forecasting system is not to try to replace an ERP. It's to augment what's in the ERP and what an ERP does, and handle the things that an ERP is not doing effectively sometimes. And like I said, if you have it all in-house, everything's running inside of your organization. You're not running, say, a lot of big supply network. ERPs tend to work a little better. The other thing that we've run into a lot as I guess practitioners building software that kind of cuts across the different ERPs is that a lot of companies in manufacturing in particular, they're not running one ERP system. They're running 2 or 3 or sometimes a dog's breakfast of like 12. We've seen it all in that regard. And ERP systems are not talking to each other in any way. So one ERP system, you say if you're an ERP system for the US and you're running SAP, you are not tying to the ERP system in France where you're buying half your product from that goes into your final assemblies, and that company is running Infor. And they've got different part numbers in their systems than you have in your systems, and you don't have any visibility into the BOM details necessarily of what's in their system, and so part numbers don't match. And corporate has a plan to get you all on S4 HANA SAP in 2029, and it's 2025 now, so you've got 4 years of trying to figure out how to manage the business, survive and thrive without relying on an ERP system that will aspire to have all the parts in it 4 years from now. That's actually a fairly common occurrence. We're seeing less. Our experience in the marketplace has been seeing less of companies deciding to be IT driven, where they say we're all going to be on one ERP system and it's going to work like an orchestra, and they more resigned to or of the approach that they're going to make do with what they have and put other technologies on top of the ERP systems to more quickly homogenize a bunch of disparate data out of different ERP systems and planning systems and Salesforce and forecasting systems and the like, to have as quick as possible and effectively as accurate as possible a good view of the world quickly. Other challenges in bill of material cost forecasting. It's a big data endeavor. So, the purpose of such a system is not to replace an ERP. I can tell you that the places that we've done these types of implementations, they're running big ERPs, they're big companies running typically SAP, and they're not, there's something that SAP is not solving for that they feel strongly that they need to get out of the tool, out of a modeling tool. So it is a big data endeavor. Just imagine, this is just representative examples that are realistic, but 1,000 products, each with 1,000 components and sub-assemblies per finished good times 2 suppliers, 5 plants, 20 months outlook, and 10 scenarios very quickly equals 2 billion rows of results in a data set to analyze, to try to drive to use to make decisions. It's not something that happens offline in Excel with any level of accuracy, precision, and timeliness. Thus, there has to be something that comes in over top of it to do that type of work and that type of math. Other constraints, I already mentioned it, but BOM data availability itself. Which BOM to use? There are multiple BOMs in a company of many of different levels of quality, data completeness, multiple ERP systems, the efforts of getting everybody all the data to use the same master data. So a SKU is a SKU is a SKU regardless of which of your business entities or facilities is producing it. That's something that takes a bit of work. It's kind of taken for granted that it just the stuff should all line up, but when the rubber meets the road, it typically doesn't, and there's some degree of data cleanup and data readiness that has to happen before you can really have reliable detailed bill of material forecast information set. And then getting the costs themselves. So this probably sounds trivial. It should be in your ERP system, but in the case of like the Apple example, or like a electronics supplier example, the costs are not in the ERP system because the the Apple isn't buying said thing. They're negotiating on behalf of like a tier 3 supplier, saying we're going to have all this volume, so this little widget that's in our phone needs to cost 1.23 cents. But that cost doesn't actually exist in Apple's ERP system necessarily. I could tell you in other similar types companies, including those that have been clients of ours, those costs are not in the ERP system, and so they have to have a place to put it, and then be able to forecast on it what happens when that cost changes as well. I know we're got a bit more to cover. I want to get, in the essence of time, I'm going to kind of go a little more quickly here. But challenges of bill of material and cost forecasting, they're a little bit redundant here, but inaccurate BOM data, price volatility, currency fluctuations, also for international business, hidden and indirect costs, the complexity of multi-level BOMs, and also multiple supplier BOMs. So if you buy the same assembly from 2 different suppliers, it might actually have different sub-BOMs in it, and manual processes and lack of integration, which is probably the big one here. So in the special case of own design manufacturer and contract manufacturing, that's really the dynamic I mentioned before. So I'm not going to recover it here now, but we will talk about it more during the demo portion. So moving on here, Rafe, do you want to jump in and I guess there's the question. There we go.
So I've just launched the poll. Please answer it promptly so we can see how well everyone's been listening, and we'll see the results in a moment. Okay, so I'm going to end the poll and share the results. And it looks like 91% said all the above, which is the correct answer. So good job to all the attendees, and we'll keep moving on.
All right. So solutions and benefits. So as I mentioned, it's what we're doing here is not rocket science, but it's a pretty big data problem, and it's a math and a business logic problem, and it's a problem that, to be solved correctly, it needs to be solved rapidly as new information comes in. So it's not a one and done sort of thing. It's something that should be refreshed as often as new information comes in. So weekly, daily, a lot of costing projects that we are involved with that aren't BOM related, they're updating monthly when the financials close. BOM's different. Ideally it's running on a more frequent basis to give the people that need the information, procurement people, commercial organization, even planning and people, the most accurate view of the world based on the information as the business changes every day. New prices negotiated, let's roll it in, see what the impact is across our total spend, ideally instantly, as quickly as you can. And so that's a need that requires something that's drastically more purpose built than the world's biggest spreadsheet that somebody tried to solve the problem with. And it's also too big of a problem to solve in a planning and consolidation system. We've seen companies try that, and the like planning consolidation systems are great. They're super important. They don't handle the data volumes that we're talking about here when you're talking about hundreds of millions or billions of rows of intersections of results that have to roll up. That's not the purpose or the kind of the skill set of those tools. So appropriate technology is the answer. I already mentioned, spreadsheet jungle is not the way to do what I'm describing should be done. BOM forecasting isn't rocket science. It's just a lot of math, and that's happening again on a very regular, routine basis. And it requires a tool that's equipped to do the job. Another thing worth noting here is that typically the organization is distributed, is running these types of models and contributing to these types of models, so that the system needs to allow for inputs to come from multiple systems and lots of different people. Typically there are people such as buyers who negotiate with vendors who actually have to put costs into a system that that they've negotiated that their parent company isn't even procuring, so they don't end up in the ERP system. There has to be a place for that information to live and then roll up into the cost bombs. And it's a known opportunity. So most companies that are doing this type of thing, oftentimes they're doing it with gut feel. And kind of highest paid person makes a gut feel based on all the spreadsheets he or she has seen, and make a call and change suppliers. Was that the right thing to do? Maybe, maybe not. If you could have run some more detailed BOM scenarios, you might have made a better assessment. And all the way to the CFO, organizations know that automating back office processes like the collection of this pricing data, cost data, cost modeling data, is something that they want to continue to drive to like more automated, or at least more common way of gathering information that still has to come from people that's not in your ERP system. So our approach is PlaidCloud. That's our company, and this isn't going to be a sales pitch, but there are other tools where you could do this sort of thing in as well. But the purpose of the tool and the capability of the tool are to allow the connection to all the systems that are needed for input to a BOM model. So MRP system, forecasting, CRM, Salesforce for forecasting, whatever it is, planning and forecasting, high-level forecasting and consolidation systems, to connect to that data, get it to play nicely together. So if part number is one thing in one system, something else in another system, get it lined up so it matches, and allow contributors of information to contribute collaboratively, and then to do that at scale, large, multinational or worldwide organization, and then to provide results that are actually actionable and useful to the people that are striving to make decisions from it. A lot of times what's happening here is there's a lot of buyers who are managing negotiations of different components and subassemblies, getting that information into the system, and then there are people at the higher level who are then making kind of make versus buy decisions, or let's move these operations from China to Mexico types decisions, and they need to know what's the total volume here, what's the total volume there, what suppliers are involved, and how much volume is on each supplier on a forward-looking basis. So benefits of BOM cost forecasting, and I think I kind of already touched on some of these. I'm going to start with the third one, and we'll come back to the others. But rapid and effective responses to engineering changes. So typically in a engineered product organization, changes to a product to take cost out, one of the main jobs of an engineer, are evaluated based on the potential to take cost out. And it's important to know what's cross that with the volume, to know what the total impact is over time across all of the finished goods that potentially use that subassembly that's being re-engineered. Smarter production planning and supply chain management. It's kind of maybe not day-to-day stuff that's in your ERP system, but beyond that, the stuff that's more higher level, strategic. Where should we produce something or buy something from? The high level make versus decide, buy or buy from whom decisions, driven by as accurate as possible consumption and cost information for every component in your product across time. And also even optimize pricing strategies. Most companies are not attempting to do cost plus pricing unless they're in a commodity business, but you certainly want to at least know what your cost is when you're selling something, and getting your forward-looking BOM costs as accurate as possible helps drive pricing, and frankly, what should we be selling and what should we not be selling. Actions driven by bill of material forecasting include outlooking. What is if we can model different scenarios, what is the impact overall of different outlooked, say, engineering initiatives, and what is the financial impact of those. Supplier management negotiation, strategic planning, onshoring versus offshoring, and then the what-if capabilities to analyze impact of tariffs, impact of supply disruptions, and just the impact of strategic decisions for other things, like if we want to move something from one supplier to another to gain volume, to have maybe more prominence and more leverage with that supplier. What's the impact of that? And then lastly, related to supply disruptions, really, disaster preparedness. What happens? How exposed are we if a supplier goes offline or a region goes offline or we can't get products out of a given country? What should we do to supply as many customers as possible, given a certain linchpin type of SKU becomes less available? We don't want to produce 95% of a million computers. We're better off to produce 100% of at least a portion of those. So disaster preparedness is something that this data can be used to then feed a subsequent disaster preparedness analysis or a subsequent disaster preparedness model. So another question here, Rafe.
Okay, we have our second polling question. Can please answer expeditiously, and we'll look at the results momentarily.
I think that last bullet there, Rafe, was supposed to say all of the above.
You're right. Last one should say all of the above. Okay, I'm going to end the poll and share the results. And despite my typo there, everyone got the right answer pretty much. The answer was all of the above.
All right, moving on. Case study. So case study that I wanted to discuss, and I've already discussed it a bit, but is the example of an electronics company with the global supply chain. And the company needed a single system to manage bill of material cost forecasting with an 18 to 36 month cost outlook in order to support the following objectives. Number one was supporting negotiation, just understanding, having a good view of over the next 2 to 3 years, how much money, how much of given key components they're going to need, and then figure out where to place the buys of those components. Oftentimes not the fancy stuff, but just like little screws, like stuff like that. This stuff that is part of building an electronic device like a computer. Impact of engineering changes. Forecast the impact of proposed cost reduction engineering design changes. And the way this actually was implemented and what was needed was the client needed to be able to forecast the impact, to collect the impact of different engineering changes. So in addition to procurement and other people having input into what goes into the tool, engineering as well had to have access to enter initiatives that would say lower a given subassembly cost by X cents or X percent, and then be able to look at that across time and do so in both a weighted and unweighted way of looking at it. So engineering changes can be calibrated, be like high likelihood, medium likelihood, or like low likelihood, with like different coefficients of associated with those, like high likelihood being 75%, or guaranteed likelihood it's going to happen 100%, or things that are more aspirational. Hey, what if a year from now we just did something different? We're able to re-engineer this and took a chunk of cost out, but with a low likelihood. Be able to categorize initiatives based on those types of categories as well. And lastly, because of COVID and even because of some domestic things that happened, I mentioned the ice storm in Texas, was the impact, like how do we supply as many of our customers as we can, given an unexpected short-term shortage of certain types of components or sub-assemblies? Like, what do we do? And we don't want to build 95% of a whole bunch of stuff. We need to build, 100% of some sub-portion of that stuff. And having the data all the way down to the gnat's eyelash level detail of what component is in all of my bills of material, what's the volume of it, is a very useful tool in driving the most correct answer to that type of question. And doing so kind of quickly in sort of COVID sort of very atypical, like almost emergency level circumstances. Um, and so the in our case, the BOM info from the engineering system was combined with the forecast, which came to us through the ERP system, and intermediate costs, the actual costs of things that our customer or the own design manufacturer um, was responsible for negotiating, but didn't actually buy. So it the costs weren't accurately maintained in the ERP. Those costs were loaded from in some cases legacy systems, but mostly from a buyer that's managing legacy state was managing these things in Excel, which isn't what we want. So the implementation involves really data homogenization, data unification, and then measuring timeliness of good information feeding the system so that what a cost roll up in a forward-looking BOM would have everything in it so it rolls up accurately. So a few considerations. So I already kind of touched on them, but planning and data governance. So for a system like this, it's going to lay over top of a number of different systems. Data governance is a big deal. It's a really big deal for companies that have multiple MRP systems floating around. But even if there's just one, that system's information needs to tie to the engineering system's information. They often don't. And also with the ability to join it to a forecast that might be coming out of a CRM system, et cetera, et cetera. Collaboration across the distributed team, really important. A system like this is going to serve people, say maybe a corporate, but the information that's feeding it, some of it's going to be collected from a lot of, say, low-level buyers or analysts from various regions of the company where the company does business. Integrating complexity and harmonizing BOM roll-up and costs. That basically it's driven by data governance. Again, the math of rolling BOMs up isn't complicated. You can do one in Excel. You just can't do, a million times 18 periods quickly in Excel and have it turn around really fast. So keeping all the skids greased by having really good data integrations where you need them and setting things up so that things can run kind of automatically as a going concern is an important thing. So in our experience, these things run either daily or weekly with all of on a routine predictable cycle. So it's just every day or every week it's time to make the donuts. New information comes out automatically based on the best input available at that point in time. Accurate forecasting, given the forecasting is going to drive consumption. With different scenarios, we have the ability to toggle in different forecasts. So there's, say, the forecast from commercial, and there's a forecast that, say, the CFO and operations think is really going to happen over the next 6 months. And so you can kind of build a scenario with either of those to kind of predict see how things are going to turn out either way. Training and onboarding and keeping the relevant parties so that they know what how to use the system is important. And then lastly here is artificial intelligence. The system we implemented didn't actually have AI in it at that point, but the opportunity is there now to augment with AI in two ways, really. One is to get the fuzzy data costs that are, say, in spreadsheets or somewhere else into the system more efficiently, and to maybe more accurately approximate costs when they're not available. So an approximate cost in a BOM roll-up is better than a null, and nulls just basically cause things to break and be wrong. But if we don't have a cost for screw XYZ, but we've got 10 other screws, that are kind of similar, and we can use some AI and to infer what the approximate cost is for that screw, it's better to have that sane estimate than it is nothing at all. So that's one opportunity for AI to play a role in doing this in the future. And another way would be specifically to the disaster preparedness, to be able to more quickly punch out different scenarios. What happens if this happens? What happens if that happens? Can I very quickly turn around like a fully built out scenario? There's some opportunities there to use some AI to be able to churn those out more quickly, because each scenario right now has a cycle time to it of a couple hours. So Actually, Rafe, we have a third question here. So Rafe's on mute here. So what are the challenges and considerations of BOM cost forecasting? And there's the 4 options there. Go ahead and answer those. Everybody got the trend. It's all of the above. All right. Good deal. So actually, I forgot to jump into any sort of demo. And so I do have a little bit of a demo provided, but we are just about out of time. And so I'm going to focus more on taking some questions. I'm going to bring up a couple of things here just to see a little bit of what the results of a BOM model look like out in the wild. So this is just an example of capturing spend by different types of like sub-assemblies. And this type of information is useful for knowing what your overall spend is and what your spend by supplier is. And then this information can be sliced and diced a bunch of different ways that basically give you information that helps support, I mentioned negotiations, but then myriad of different options there. Even figuring out like which sometimes there's cases where certain components maybe can be subbed out and substitute components used, and that's especially in time of shortage. That's something that's useful to be able to see kind of bird's eye view. What's actually happening here? We have all sorts of different reports and dashboards that can be built off of this data. The important thing is the data itself is super granular and it can be rolled up a myriad of different ways, and it's refactored, it's recalculated, not quite real time, but very frequently, so that what's produced here and in these reports is the current view of the world, the best view of what's going to happen in the future, based on the information that came in as recently as this morning. It gets reflected here, and people have a kind of always as accurate as possible view of what the future is. And last on that note, let me just see if there's one here I want to flip into. There's really not. Did look at an actual bill of material in the tool in software and drive it around a little bit. I'm not going to spend a lot of time there, but this what I did want to show was one example of a table. So this is an example of a scenario of BOM results, and I'm not going to spend a lot of time here, but the data itself has a lot of different attributes, and you can see here TLI, that basically is top level. It's like a finished good part number, and location's important, and then there's things like we call key supply chain. Basically, there's internal keys for BOM routings, and this would be something that came out of an ERP system that's telling us where each part what each part goes into, and where it goes into that assembly and where it comes from. So it's more than just part A rolls into part B. It's part A at this location rolls into part B at that location. That's a full proper BOM routing. And then with all that information kind of at that super granular level, it's just from that you can get attributes like supplier and country and part type and module type and all these other different types of attributes can be pulled off of this very rich data set very quickly. And this is a sample set that has like 1 million rows, but typically in a real implementation, this is going to be like more like 200 million rows of super granular data here, also because each record here, each part rolling into each top level assembly is in this data set, say 36 times, because we're covering 36 months of forecasted results. With all of that in mind, I'm going to go to the summary here and take some questions. So if I can hit the button there we go. So our view is that in a lot of companies, there is opportunity to do BOM forecasting better than it's being done. Typically, it's not being done at some companies, at least in certain industries, very well in the MRP, and it devolves into gut feel and spreadsheets and literally spreadsheet jungles. So our view is that a technology that's purpose built to solve this particular problem is the right way to go, and that the future is to continue to do this type of analysis and simulation as rapidly as possible. So it's not a one and done. It's not even a 1 month and done. It's a regular make a change. What happens to my expected results? Make a change. What happens to my expected results? To build that in as like an ongoing engine that's running in your business to always give you the best view of the world. So with that, I'd like to take some questions. There's one here.
And before we do, I would say thank you, Mike, for that amazing presentation. I learned a lot today, and I'm sure everyone else did. Before we do the Q&A, I do want to launch the final poll. Okay, which seems not to want to launch. Launch. Well, while we go to the Q&A, while I do launch this. Oh, okay. Got it.
All right. So with many manufacturers today performing final assembly of subcomponents, specifically integrating pre-assembled subcomponents and attaching other elements to achieve the desired functionality and appearance of the final product, as opposed to building the product from scratch. How does this impact BOM forecasting? So that's a good question, actually. So what I think this is probably getting at is a lot of times, a company is buying something in their product, and they don't really even need to care about what's inside that subassembly. It's just they know that it works. So we see this in something as mundane as like a label, right? So an engineering BOM is going to say a label is comprised of paper and adhesive and ink. We don't need to know that, like in building an engineering BOM. We know that we're paying 1 cent per label, and so we can track that cost, that as an those three components, if you will, ink and paper and adhesive, as a single assembly, and just track it at that level and roll it up from there. We don't always have to go to the lowest grain of sand that's in the engineering BOM to do cost BOM forecasting correctly.
Okay, I actually have a question that was sent to me, and it is the following. With many manufacturers today performing final assembly of the subcomponents, specifically integrating the pre-assembled subcomponents and attaching other elements to achieve the desired functionality and appearance of the final product, as opposed to building the product from scratch, how does this impact BOM cost forecasting? Okay,
that's the one I tried to answer here, Rafe, just a moment ago.
Okay.
But again, it's basically from a BOM costing model, we don't always have to go to the leaf level of costing. We wouldn't go as granular as makes sense. And so the goal here is to be able to go as low as possible, but then not any lower. And so the engineering BOM often is too precise. The manufacturing BOM is even too precise. And so basically, as you drill from a top level BOM down to the levels at which you need to forecast at, there may be a stopping point as you drill your way down. That's basically what would be our approach there. And it's kind of an off ramp to not go all the way down to the gnat's eyelash, the very bottom of the BOM, if you don't need to.
Great. We have time for one more question, but before that, be sure to answer the end of webinar poll if you haven't answered at least 3 other questions, so you do get your certificate of attendance. But the final question is, given all of the volatility and uncertainty around tariffs today, and the fact that many industries are heavily reliant on globally sourced raw materials, is this yet another reason why BOM cost forecasting isn't optional for companies today?
Yeah, so it's again, doing things, having a model that you can tune and adjust very quickly is important, because hey, tariffs are turning on and off, with the news cycle right now. And so that's a great example of something that can, if a tariff looks like it's there, and suddenly you look at the 4 o'clock news and it's going away, direct impact on your business potentially might cause you to say, you know what, we're not going to do business in Korea. Oh wait, no, yes we are. and like that quickly. And so what's the impact of that? It'd be nice to know in more detail, hey, what does this mean to our bottom line? And be able to answer that question confidently and quickly, with all knowing that all the raw data beneath is all taking that into account and then rolling it up. There's one other question here, if I may. It's with increasing cost of precious metals across the globe, how do we analyze the precious metal impact of the finished product, since part numbers will not have breakdown by metals usage? So the short answer is if you really want to account for that, you have to have some way to approximate the metals usage by parts. It's just another dimension, if you will, and that can be done with like a coefficient, basically adding a dimension to the model. But if that is an important dimension of your business, it is something that can be added to the model, and then we would manage that with basically like an adjustable coefficient for, say, the metals price, say, per month, what you think it's going to be, multiplied by what you think is the portion of said metal in the components. So it's a solvable thing. It's a matter of adding a dimension to a model to kind of fit that purpose.
Great. Well, I think that's all we have time for.
All right.
Thank you again, Mike. And PlaidCloud actually is a gold sponsor of PACE's Profits Plus 2025 conference. That'll be held September 24th and 25th this year. If you want to hear more great information from Mike and PlaidCloud, be sure to, and others, be sure to register for our conference. It's available on LinkedIn and our website. Thank you, everyone, and have a great day.
All right. Thank you.